Welcome back, focused learners. Okay, let's be totally honest for a second. Hurtling through the sky in a giant metal tube at 35,000 feet, it can sometimes feel, well, entirely unnatural. If you've ever looked out the window during a bumpy flight and thought, man, what happens if the wings just snap right off? Trust me, you're absolutely not alone. But today, we're going to dig into the hard facts behind these fears. We're drawing directly from the insights of an active commercial Airbus captain to see exactly how modern aviation turns terrifying hypotheticals into highly engineered certainties. So, our goal in this explainer is super straightforward. We are dismantling aviation anxiety. Fear usually just comes from the unknown, right? From not understanding what all of those bumps, sudden chimes, and weird weather patterns actually mean. By looking at the exact science, the tech, and the strict procedures used on the flight deck, we can transform those terrifying unknowns into well-engineered, logical knowns. Okay, let's dive into this. Here's our roadmap for today. First, will the plane break? Second, surviving extreme weather. Third, handling onboard emergencies. Then we'll look at the extreme scenarios. And finally, the ultimate safety net. All right, Section 1, will the plane break? The science of everyday bumps. So, a super common fear is that extreme stress will just tear the plane apart. But aircraft are designed with an absolutely incredible rule of redundancy. When engineers design an airliner, they calculate the maximum amount of load it will literally ever take in the worst possible conditions. And then, they build this massive testing jig, lock the plane into it, and literally bend the wings upward until they finally snap. For the current Boeing 777, the wings didn't snap until they went a whopping 150% past its design limit load. I mean, that is a level of stress that would just never, ever happen in actual flight. Your plane is simply not going to break. And there's a really crucial number to keep in mind here: 7.8 meters. The new composite wings on the Boeing 787 actually flex upward by 7.8 meters during testing. That is a massive amount of flex. So when you look out the window on takeoff or in heavy turbulence and see the wings flapping or bouncing around, well, that is exactly what they are engineered to do. They're not rigid. If they were rigid, that would actually stress the fuselage. That flexing movement, it's just the wings safely generating lift. Which naturally brings us to the bumps themselves. Turbulence. Look, the aircraft is not going to fall out of the sky. It's literally built to take a beating. There are two main culprits here. First up is clear air turbulence. You're flying on a perfectly clear day and suddenly, bam, it's bumpy. This is often just the aircraft moving in and out of jet streams, which are essentially massive tunnels of fast-moving air. Then you have mechanical turbulence. Think about landing at the Manchester terminal on a really windy day with a strong north wind. The air gets all churned up as it hits the buildings on the ground before it even reaches the runway. It is totally safe, it just feels, a little uncomfortable. And this brilliantly illustrates the incredibly proactive approach pilots take to those bumps. They don't just guess up there, they follow a precise, multi-step mitigation protocol. First off, they review charts showing exactly where turbulence is expected. Second, they're constantly listening to air traffic control to hear reports from other planes ahead of them. Third, if they do hit bumpy air, the plane has a specific, highly safe penetration speed that they'll adjust to. And fourth, they simply negotiate a climb or descent to find some smoother air. Easy as that. Moving on to Section 2, surviving extreme weather. Radar mapping and lightning strikes. Modern airliners are packed with highly sophisticated technology to ensure they never, ever fly blindly into a tempest. They actually have a Doppler weather radar mounted right in the nose of the aircraft. This radar sends out signals that bounce off large water droplets inside clouds, painting a crystal clear picture on the pilot screens. And it's color-coded for safety. Green means wet, yellow means it's getting kind of nasty, and red means absolutely avoid. Using this awesome tool, pilots will routinely navigate around storms, clearing them horizontally by at least 20 miles or vertically by a solid 5,000 feet. Now, let's talk about lightning strikes. People are usually terrified of lightning hitting the plane, but honestly, it's often a complete non-event. The entire aircraft has full electrical shielding. It acts like a protective shell. The internal systems are completely unaffected. Up on the flight deck, the pilots might just hear a tiny, quick crackle on the radio. After landing, engineers might find a tiny little outer burn hole, do a quick inspection, and get the plane right back in the air. And hey, if a storm is simply too fierce to land in, planes carry extra fuel reserves so they can circle in a holding pattern, or they just fly to one of their pre-planned diversion airports where the weather is perfectly fine. Okay, Section 3, handling onboard emergencies. Birds, fires, and medical events. So, What happens if the pilots suddenly become incapacitated? Well, first off, there are always at least two pilots. If one falls ill, the co-pilot instantly takes the controls. The cabin crew administers oxygen to the unwell pilot, and they immediately divert to a nearby airport with top-notch hospitals. But what about the astronomically rare event that both pilots are incapacitated? No way, right? Well, some airlines actually train their cabin crew to step in. They use the radio to call for help, trained experts talk them through the setup, and get this, the aircraft can literally perform an auto land. It flies itself down, touches down, and completely stops on the runway without any pilot input. Mind-blowing, right? Another massive fear we hear about all the time is bird strikes. Usually, it's a total non-event. The airport has intense wildlife prevention. Flare guns, loud engines, lights, all to scare birds away before takeoff. But if a bird actually does hit the plane, it might just bounce off the nose or go through the outer bypass of the engine without any issue at all. But what if it hits the windshield right in front of the pilots? Well, that glass is massively thick. It's made of at least 9 flexible, heated layers. If a bird strikes it, the glass actually has some give to it. It just bounces off. At the absolute worst, it cracks the outermost layer, leaving 8 perfectly intact, heavily reinforced layers protecting the flight deck. And then, of course, there's fire. The systems here are just astonishingly robust. In the engines, or even that little APU mini engine in the tail, there are built-in fire extinguishers the pilots can trigger instantly. Believe it or not, the most common fire threat on board is actually just some passenger deciding to vape or smoke in the bathroom. But even the toilet bins have automatic built-in extinguishers. For modern threats, like say a smoking lithium phone battery, the highly trained cabin crew have very specific isolation procedures. Up on the flight deck, pilots can isolate electrical systems entirely, and the crew is equipped with dedicated smoke hoods that supply pure oxygen alongside heavy-duty fireproof gloves. All right, Section 4, the extreme scenarios, depressurization and water ditching. Let's look at the timeline for a sudden depressurization. If the cabin altitude ever goes past 14,000 feet, those little masks automatically drop down. Pulling the mask activates a small chemical block above your seat that burns to create pure oxygen. This gives you a positive flow of oxygen for up to 22 minutes. But here's the real kicker. Look at the pilot's timeline. They immediately initiate a rapid emergency descent. They can bring that massive airliner down from 35,000 feet to a perfectly breathable 10,000 feet in just about 4 minutes. To put that into perspective, 4 minutes is fast enough to safely clear the highest peak in Europe, Mont Blanc, long before your 22 minutes of oxygen even comes close to running out. Finally, the big one. Can the plane actually land on water? Yes. Ditching is the absolute last resort, happening only after pilots have completely exhausted every single checklist, attempted every engine restart, and ruled out literally every diversion. But it is possible, and it is entirely survivable. We saw this famously when Captain Sully landed an Airbus right in the Hudson River, and years ago with a hijacked 767 in Africa. In the incredibly rare event it has to happen, the aircraft is quite literally engineered to float long enough to get everyone out safely.
And finally, Section 5, the ultimate safety net. Comparative statistics and conclusions.
So, the crucial point here really lies in the numbers. Look, human brains are notoriously bad at evaluating risk. When you get in your car, your odds of a fatal crash are roughly 1 in 5,000. But when you step onto a commercial airliner, an airliner backed by wings tested 150% past their limit, 9-layer windshields, dual pilots, automated landing systems, and individual chemical oxygen generators, your odds of dying completely plummet to 1 in 11 million. I want to leave you with this exact quote from the Airbus captain we drew today's source material from. The most dangerous part of your day will be driving to that airport. All those terrifying unknowns have literally been engineered away. Which leaves us with a pretty fascinating question to ponder. If we can make hurtling through the sky at 500 miles per hour this incredibly safe, what other quote-unquote dangerous aspects of our modern world are actually way safer than we think?